Welcome back, Logan. Hope you're getting cozy in your sofa because it's another lesson of math from your couch. Today, I want to take a look at this circle. So, we're going to start off with just a quick review, a quick recap of what we've been working on. And you'll notice that we have a chord, and that chord is called chord AB. Now, chord AB has an arc that is associated with that chord. We call it its minor arc, its corresponding minor arc. So, what we could do is we could say that this chord, chord AB, has a minor arc that we can call arc AB. So chord AB has an arc associated with it, its minor arc, arc AB. Now, there is a second arc in this picture, and the second arc is this guy. The problem is we can't name this. So if you remember, if you have a minor arc, you just need 2 points. But to name a major arc, an arc that is larger than 180 degrees, that is larger than more than half the circle, we actually need a third point. We need a point to pass through. So that's where we're going to introduce point C. So what we have here is the yellow arc, we would call arc AB. That's our minor arc that it corresponds to the chord. And then we have this purple arc. Notice that we're going to start and stop at A and B. So we're going to say A, something B, but we need to pass through C to get to the other side in either direction. So the pink arc is going to be called arc ACB or BCA. Okay, so that's enough of the review. Let's jump into today's topic. And for today's topic, what we want to do is we want to take a look at what happens when we have a chord in a circle. Now, not just a single chord, but actually two chords. So today's topic has to do with two chords that are congruent to each other. What happens if we have two chords in the same circle that are congruent to each other? Now, if you look at it just by observation, it almost looks like the arcs are also congruent. Now, when I say the arcs, I'm talking about those minor arcs right there, arc AB and arc CD. And this is our first property for today. Our property is that if this arc right here, let me restate that. If this chord right here, chord AB, is congruent to this chord, chord CD, then we can conclude, right? So if AB is congruent to CD, we can conclude that the arc that is corresponding to AB, right? So this arc here must also be congruent to this arc here that corresponds to CD. Now, what's nice about this is that the converse statement is also true, which means we can go ahead and throw that arrow sign on the other end of that statement. So if the arcs are congruent, then the chords must be congruent, and if the chords are congruent, then the arcs must be congruent. All right, so let's take a look at our first example. In this example, we have a circle, and we want to know, are any of the chords congruent to each other? Are any of the chords in this picture congruent to each other? So I look at my three chords, chord AC, chord AB, and chord CB. And right off the bat, I notice that chord AC has an arc that is 160 degrees associated with it. The same thing can be said about arc AB. Arc AB is 100 degrees, which means the chord AB has an arc that is corresponding of 100 degrees. Notice that the two arcs are not congruent. The fact that the arcs are not congruent now leads me to understand that segment AC, chord AC, will not be congruent to chord AB. All right, but one of the things that I notice about a circle is that there are three chords that are being drawn and there are three arcs partitioned. So if I wanted to, I could somehow figure out if chord CB is congruent to either of those chords. But to do this, I would need to know what this arc is. The good news is all the arcs of a circle must add up to 360 degrees. Remember, all the arcs of a circle add up to 360. So I have this arc is 160, and since it's adjacent to this arc, which is 100, we can go ahead and add them. This is a total of 260 degrees, which means if I know the full circle is 360, and I currently have 260, by subtracting them, I will get the leftover amount of 100. Noticing that arc CB is congruent to arc AB, I can now use this property here that says that if the arcs are congruent, then the chords must be congruent. So I can now conclude that chord CB must be congruent to chord AB. So I can say that CB is congruent to AB. And we're talking about the segments or the chords here. All right, let's move on to our next example. So our second example, what we have here is what is the measure of the highlighted arc in this picture? So we're talking about this arc right here. How much is this arc? I don't know how much this arc is, but I do know that the chord associated with arc TS is congruent to the chord that's up here. And this statement, this property says that if the chords are congruent, then their corresponding arcs must be congruent. So I now know that arc ST has to come out to a total of 85 degrees. So this arc right here will be 85 degrees. And this is pretty much the first property right there. If the arcs are congruent, then the chords are congruent. And if the chords are congruent, then the arcs are congruent. Now be careful, this is only true about chords and arcs in the same circle or in circles that are congruent. Okay? All right, so now let's take a look at our second topic. Our second topic actually has to do with something a little bit different. This topic has to do with what happens if a chord, in this example MP, what happens if chord MP is perpendicular to the diameter AD. All right, so what happens if that was to occur? And this is our second property today. Our second property is that if a diameter, right, so if AD is perpendicular to a chord, so if a diameter is perpendicular to a chord, so if AD forms a 90-degree angle with a chord, then this diameter does two things. The diameter is going to bisect. The diameter is going to bisect not only just the chord, but it's going to bisect both the chord, so we're going to bisect the chord and the arc. So we can now say that this chord is now cut into two equal pieces. The same thing can be stated as true for the arc MD and the arc DP. They must be congruent to each other as well. So if you ever see a diameter or a part of the diameter perpendicular to a chord, you can then logically conclude that the chord is going to be bisected, so the parts of the chord are congruent to each other, and their corresponding arcs must also be congruent to each other. So those guys are going to be congruent to each other. All right, so let's take a look at our last example for the day. All right, so given this circle right here, I need to find two things. What is the measure of arc AB? And then what is the length of segment DA given BA? Okay, so we take a look at this. Now you'll notice that we have a chord BA, and in addition to having the chord, we also have a piece of the diameter called the radius, a piece of the diameter which is perpendicular to that chord. And this theorem says that if the diameter or a piece, I know I didn't write that down, but if the diameter or a piece of the diameter, the radius, is perpendicular to a chord, then the diameter bisects, this radius, the part of the diameter bisects the chord. So this is going to be congruent over here. And it also bisects the arc. So we could say that the arcs are congruent to each other as well. You'll notice that arc AC is 62, which means arc BC must also be 62 because they're going to be congruent to each other because of that perpendicular radius. So now that I know that they're both 62, AB is just the sum of those two arcs added together, which would be 62 plus 62 for a total of 124 degrees. The second part to this question is what is DA if BA is 24? Now BA starts at one end of the chord and ends at the other end of the chord. What the radius does is because it's perpendicular to that chord right there, it must cut the 24 in half, which means this piece is going to be 12 and this piece is going to be 12. So we can conclude that DA is equal to 12. All right, that's it for today. Do the best that you can. If you have any questions, go ahead and email me or drop by virtual office hours and I'll try to clear them up. Otherwise, I hope to talk to you guys pretty soon. Bye.